and radiation. So what is the meaning of this? The meaning of this is, you can see here, radiation. First of all, I will discuss radiation have wave nature and radiation have the particle nature also. That is why we are saying dual nature of matter and radiation. So what is the meaning of this statement? See, so basically what is radiation? Radiation is light. The light is a radiation. So this radiation have the wave nature also. We have seen for the wave nature what we have seen. Light have the wave nature. We know earlier. Earlier what we know. What is light? I told you light is a wave. Light is a form of energy and it is a wave. And why it is a wave? Because light shows the phenomena like reflection, like refraction, like diffraction, like polarization. So these are all the phenomena. These are all the phenomena of wave. So light shows these phenomena. So we can say light is a wave. Light is a wave. But in this chapter, we will discuss light is a particle also. Light shows the particle nature also. Why photoelectric effect? We will discuss the photoelectric effect, and that photoelectric effect will be defined by considering light as particle. Okay, so light is showing dual nature. So photoelectric effect. So what is the meaning? You can say light or radiation have wave nature also. Why we are saying have wave nature also? Because of the refraction of light, etc. Understanding, Matthew? Light have the dual nature.
Yes, sir.
Why the light have the dual nature? Light have the wave nature also. Light have the particle nature. And why I'm saying the light is having the particle nature, because we will see the next topic is the photoelectric effect, and you will see that photoelectric effect proves the particle nature of the light. Light is a particle also, something like particle. Now we will discuss matter. Matter also shows the dual nature. Like light, like radiation. What is the radiation? Radiation is the light. What is matter? Matter, you can say the marker of, or the pen or laptop is matter. Anything which has space, anything which has space and have mass is matter. So basically, you can take the example of the pen. So pen will show the particle nature, because we know pen is a particle. Pen is made up of particle, but pen will also show the wave nature at the same time. So this matter also have particle nature as well as wave nature. Matter also have the dual nature. Radiation also have the dual nature. Matter will also show the wave nature. This also we will discuss in this chapter. So radiation have dual nature. Radiation have the wave nature and radiation have the particle nature. Okay, particle nature will be proved by the photoelectric effect, and matter also will have the particle nature as well as the wave nature. So dual nature of matter and radiation. After this, we will discuss the photoelectric effect. Very, very simple phenomena. And this is, I will say, is discovered by many scientists, but the credit of the photoelectric effect is goes to the Albert Einstein, and he got the Nobel Prize also for this. So, what is the photoelectric effect? Basically, before the photoelectric effect, I want to tell you something. Photoelectric effect basically proves the particle nature of the light. Actually, the whole story begins with the light. Begins with light. So, what happened in 1675? In the year 1675, Newton discovered that uh, particle corpusculus theory. Particle corpusculus theory Newton suggested, And in the particle corpusculus theory, Newton considered light as a particle. Newton considered light is made up of particle. But after that, in 1801, there was a scientist Young. So he has done one Young's double slit experiment that I will discuss in the wave optics. So, with the help of that experiment, it is proved that light is showing the interference, and interference is a phenomena of wave. So, Young's proved that light is a wave. Okay, and after that, some scientists also proved that light shows the diffraction and polarization. Diffraction and polarization also is a phenomena of wave. So, after Newton, it was proved that light is a wave. So they denied the people denied the Newton's theory and said that Newton was wrong. Light is not a particle, light is a wave. After that, in 1905, what happened? Einstein came and some other scientists came. They discovered the photoelectric effect. So I will say that Einstein discovered the photoelectric effect. But the truth is that uh, other scientists also have some contribution in that. So by the way, that is not our topic. So in 1905, Einstein came. So he discovered the photoelectric effect, and photoelectric effect is a phenomena of particle. Photoelectric effect again is proving the particle nature of the light. Now Newton said light is a particle. After that, Young's double slit experiment said light is a wave. After that, photoelectric effect said light is again is a particle. So it is assumed that now it is accepted that light has dual nature. It has the nature of a wave. Sometimes it shows the sometimes it will behave as a wave. Sometimes it will behave as a particle. Okay, so that is why we were studying. Now, what is the photoelectric effect? What is the photoelectric effect? Suppose this is a metal surface and these are the free electrons on the metal surface. Okay. In metal, we know there are the free electrons because metals are the conductors of electricity. And why the current in the metals flow? We know due to the free electron in the drift velocity we have seen. In the drift velocity, what we have seen, due to the free electrons, there will be the current when you apply the electric field. So by the way, so these are the free electrons on the metal surface. On the metal surface, there are the free electrons. And these are some light radiation. Okay, this is the radiation. Radiation of high frequency. Oh, I have already written. Understanding this is very interesting phenomena and very easy also. So basically, what is this? This is basically a light, you can say, or you can say radiation of high frequency or low wavelength. Radiation of high frequency or low wavelength. So these radiations are falling on the metal surface. These radiations are falling on the metal surface, and on the metal surface, there are electrons. So what is happening? This metal radiation is falling on the metal surface, and electrons are ejecting out. Electrons are ejecting out from the surface, and this phenomena is known as the photoelectric effect. So basically, this proves that this phenomena is basically proof that this light is coming in the form of wave packets. Basically, this light is coming in the form of wave packets or quanta. I will discuss that again. These are wave packets or sometimes quanta. So basically, this is explained with the help of this. Actually, this is given by the Max Planck. So light is made up of wave packets or quanta. So when these wave packets, or basically these are known as the photons. These are known as the photons. So so light is made up of a photon. Okay, light
Okay.
is made up of a photon, and these photons are coming. Okay, These photons are coming, and these photons are striking to the electron, and that is why the electrons are ejecting out. So basically, what is shown, it shows that light is made up of photons, particle nature. So
Yes, sir.
now there are some conclusions. Light consists of a wave packets called photons, or these photons are known as the energy packets or quanta. So basically, this name wave packets is given by the Max Planck. There was a scientist Max Planck, and Einstein given the name energy packets or quanta. So by the way, you have to remember, light consists of a wave packets. Light consists of a wave packets called photons. So basically, you can say light is made up of a photons, and these photons have some definite energy. This is the first point. After that, the mass of the photon is not defined. Like mass of each and everything, you can say the mass of the laptop, the mass of the pen is defined, 1 kg, 2 kg, 3 kg. But in case of this photons, these photons means from this is consist of no mass. Okay, the mass of the photon is not defined in sense of the Newtonian mechanics. So basically, with the help of the Newtonian mechanics, mechanics means with the help of the spring balance or weighing machine, we calculate the mass. Not the weighing machine, with the help of the spring balance, we calculate the mass, and that is based on the Newtonian mechanics. So with respect to the Newtonian mechanics, the mass of the photon is not defined, but the rest mass of the photon is zero. What is the meaning of rest mass of the photon? If this photon will, if these photons is in the rest condition, then the mass of these photons will be zero. All photons to travel with 3 into 10 to the power minus 8 approximately in air or vacuum. Means all photons travel with the speed of light. Photons are neutral in nature. What is the meaning of this? It means photons is neither photon is neither positive nor negative. It is neutral. Each photon have definite energy and definite momentum. Each photon have definite energy and definite momentum. So what is the meaning of this? The photons have the energy as well as the momentum. So we'll discuss what is the energy of photon. So energy of photon I will represent with E. So this energy is given by hc by lambda or h into f. What is h? H is the Planck's constant. H is the Planck's constant. And the value of the Planck's constant is 6.626 into 10 to the power minus 34 joule second. And what is C? C is the speed of light. Lambda is the wavelength of the radiation. Lambda is the wavelength of the radiation. Lambda is the wavelength of radiation. F is the frequency of radiation. Okay, F is the frequency. So energy of the
Sir, you're not sharing the screen.
oh shit, you are telling me now.
Yeah, when I thought you were just saying the topic and then we came to the diagram and then
Okay,
yeah.
sorry for that, and I have done.
No problem.
Okay, I'm telling again. Sorry, I was thinking that you are just okay. What we have done
For the last 5 minutes, like yeah.
from the last 5 minutes. Okay, when I was
We
telling
saw this,
you,
yeah,
yeah.
from
Okay,
rest mass.
okay. So basically, what is happening here? These are the photons. These are the radiations. These are the radiations of high frequency or low wavelength. So these are the radiations. These are the radiations of high frequency or low wavelength. So basically this is light, and this light is made up of photons, or sometimes this is known as the wave packets, or sometimes quanta. Okay, so you can say light is made up of photons. So photons are coming like this and incident on the metal surface, and on the metal surface there are free electrons, and these free electrons are ejected out due to the photons incident on the surface, and this phenomena is known as the photoelectric effect. Okay, so now we know that from this, what are the conclusion? Light consists of wave packets called photon. Light consists of wave packets called photons, and sometimes we call it energy packets or quanta. The mass of the photon is not defined in sense of the Newtonian mechanics. Rest mass of the photon is zero. All photons travel with 3 into 10 to the power 8 meter per second. Okay, with means all photons travel with the speed of light. What is the speed of light in air and vacuum? We know 3 into 10 to the power 8 meter per second. Photons are neutral in nature, means they do not have the negative or the positive charge. They are just neutral. Okay, each photon have the definite energy and definite momentum. So the energy of the photon is given by hc by lambda. Energy of the photon is given by h is the Planck constant, c is the speed of light, and divide by lambda. And it is also given by hf. And what is h? H is the Planck's constant, and the value of the Planck constant h is equal to 6.626 into 10 to the power minus 34 joule second. And what is lambda? Lambda is the wavelength of the radiation. F is the frequency of the radiation. After this, what is the momentum? Momentum of the uh, photon. So momentum of the photon P is given by h by lambda. Okay, h is the Planck constant, lambda is the wavelength of the incident radiation. Okay, one more point: all collision between the photons and the matter particles, like electron, are perfectly elastic. Now you can see these are the radiation. These are the radiation. Now we know that radiation is made up of photons. So these are the photons, and these photons are striking on the electron. So means there is a collision between the photons and the electron. So this collision will be considered as elastic collision. And now what is the meaning of the elastic collision? If you remember 11th class, elastic collision is that collision in which the momentum is conserved as well as the kinetic energy is also conserved. So means the initial momentum P is the momentum is equal to the final momentum of the system. Okay, and initial kinetic energy is equal to the final kinetic energy for system. Okay, after that there is one more point on increasing the intensity of radiation. On increasing the intensity of radiation means if you will increase the intensity, what is the meaning of the intensity? If you will increase the frequency of the radiation, the number of photon increases, but the energy of each photon does not change. What is the meaning of this statement? If suppose these are the radiation of frequency f, okay, these are the radiation of some intensity. For example, if you are increasing the intensity, so the energy of these photons will not increase, but at the same time the number of photons will increase. Okay, the number of photons will increase, but the energy of the photons will not increase. So I will explain this with the help of this example. So suppose you have two light bulbs, one of 50 watt, another of 100 watt, and both light bulbs are of yellow color. So if they are of yellow color, so they have the same wavelength. They have the same wavelength. Both have the same wavelength. Now one bulb is of 50 watt and another is of 100 watt. So intensity of this 100 watt will be more as compared to the 50 watt. Intensity is more. So what is the meaning of the intensity is more? If suppose uh, in 1 second this is giving 5 photons, okay, 5 photons. At the same time, this bulb will give 10 photons or more photons. Means on increasing the intensity, you are increasing the intensity, number of photons is increasing, but but the energy of individual or each photon will not change. Okay, you will get the yellow color light from a yellow color bulb, not a red color light. Okay. Okay, so now you can take the screenshots. Hello, Nafisa and Nawal.
Hello, sir.
Nafisa, why you are so late today?
Sir, I went out today and I just got home
O- Okay,
and
okay, fine.
ate.
Okay. So basically, this is the radiation. Radiation have dual nature, wave nature as well as particle nature. Matter also have dual nature, particle nature as well as the wave nature. So this radiation is basically light. So light is showing the reflection and refraction. And reflection are the phenomena of wave. So that is why we say radiation shows wave nature. And light also shows the photoelectric effect. Effect explain the particle nature of the light. So take the screenshot.
Yes, sir.
Okay. So take the screenshot. Done.
Yes, sir.
Yes, sir.
Okay. Now see. One more thing. Basically, radiation is what? Radiation is the photons. Okay, and photons have the energy. Basically, you can say radiation is the energy. So you are giving the energy to this metal surface. That is why the electrons are ejecting. But how much energy you have to give so that these electron will eject out? Okay, if you will give very less energy than required, then the electron will not ejected out from the surface. So there is a specific amount of energy that will be required, okay, so that the electron should eject out from the surface. Okay, so next topic is the work function. So what is work function? Work function is suppose this same diagram. You are giving, this is the radiation of high frequency or low wavelength, okay, and these electrons are ejecting out, and basically those electrons which are ejecting out known as photoelectron. Now work function is represented by phi. Now what is work function? Work function is the minimum amount of energy required to eject an electron from the metal surface. The minimum amount of energy required to eject an electron from the metal surface is called work function. So what is work function? The minimum amount of energy you are giving to the metal surface so that an electron is ejected out from the surface. That is known as the work function of the surface. So the work function depends upon the nature of the surface or type of the surface. Okay. So the work function depends upon the nature of metal. So now what is work function? Minimum amount of energy to eject an electron from the metal surface is called work function. Suppose you are giving, suppose the work function of this metal surface is 2 volt. Okay. The work function of this metal surface is suppose 2 volt. And you are giving the energy to this surface as 1 volt. So in this case, you are giving less energy than the required energy to eject an electron. What is the required energy to eject an electron? 2 volt, but you are giving 1 volt. Now you are giving 1.5 volt. Now this is also this energy is also less than the required value. Suppose you have given 2.5 volt, 2.5 electron volt of energy you have given, and required energy is 2 electron volt. Now this time you have given more energy than the first function. So the electron may eject from the surface, Not necessary that electron will eject from the surface. I will explain why. So minimum amount of energy. Okay. So now for some metals, there are the work function given. For cesium, the work function is 1.9 electron volt. Electron volt is basically the unit of energy. Potassium 2.2, copper 4.5. What is cesium, potassium, and copper? These are the metals. So metal have the low work function. So just as example I have taken, cesium has 1.9 electron volt. So work function depends upon the nature of the metal. If you will change the metal here, nature of the material or metal, the work function will change. And what is work function? The minimum amount of energy to eject one electron from the metal surface. Now remember this point. If we supply, this is the energy, E is the energy supplied to the surface. Okay, energy supplied. And what is phi? We know is the work function. And what is work function? The minimum amount of energy required to eject an electron. If you are providing the energy that is greater than the work function, it is not necessary that electron is ejected out of the metal surface. If you are providing an energy which is greater than the work function, electron may come out. Now why is this? Suppose the work function of this surface is 2 electron volt, and you are providing the energy of 2.5 electron volt. Understand why? Why, if you are providing an energy of 2.5 electron volt, then why there are the chances the electron will not eject out? Suppose you have given the 2.5 electron volt of energy, and 2.2 electron volt is spending out in ejecting, and 0.5 volt remaining energy the electron is ejecting, but there will be around the ejected electron. For example, this electron is going to eject now. This electron is now going to eject. It gets it have the energy of 2 electron volt. Now it is ready to eject. But what happened? There are other electrons also on the surface. So somehow, if this electron is collided with another electron, in that collision, the energy will be wasted. So due to that, it is possible that electron may or may not come out. If the electron not wasted the energy, not wasted the energy in collision, then it will come out. If the electron has wasted the energy in collision, that it may not come out. It will not come out. Okay. So means if you are providing an energy more than the required energy to eject, so what will happen? You have given the energy to the electron. For example, here you have given the 2.5 electron volt energy to the this electron. Now this electron have more energy, so it should eject from the surface, but this electron has wasted this energy in the collision with the neighboring electron. So there are the chances that this electron may not come out, or it may come out if this energy will not be wasted. Okay, so for example, we will assuming that the electron is not wasting the energy in collision right now. So you have given 2.5 electron volt to the electron. Okay, and for this electron, what is the energy required? 2 electron volt. So now uh, you have given 2.5 electron volt. So 0.5 electron volt energy is the extra energy, is the extra energy having extra energy have electron. Okay, 0.5 electron volt is the energy that the electron have. So that 0.5 electron volt energy will be the kinetic energy of electron. Okay, that 0.5 volt will be the kinetic energy of the electron volt. Okay, the electron will move. So during the motion, what type of energy will be there? There will be the kinetic energy. Okay. So next topic is the maximum kinetic energy of the ejected electron. So you are giving the energy and electrons are ejecting out. You have given E energy and electrons are ejecting out. Okay. Now we can take one example. Suppose you have given 8 electron volt of energy. You have given here 8 electron volt of energy to electron, and work function of the surface is 2. Work function of the surface is 2. In first case, we are assuming wasted in collision, means this is the energy wasted in collision is 0. So you have given 8 energy, 8 electron volt. 2 electron volt will be uh, spended for the work function. So what will be the remaining energy? 6 electron volt, and that remaining energy will be the kinetic energy of electron. So here the energy will be 6 electron volt. Okay, so this kinetic energy is in electron volt. Now here in this example, you have given 8 electron volt. 2 electron volt is wasted. 2 electron volt is wasted in is spended in the work function, because for electron ejection there is a requirement of 2 electron volt. So here 2 electron volt is distributed, and here 3 electron volt is wasted. Now what amount of energy wasted? 3 plus 2 spended, or you can say spended. 3 plus 2, so 5 electron volt is used. 5 electron volt energy is used. So you have given 8 electron volt. So here the remaining energy will be 3 electron volt, and that will be the kinetic energy of electron. Suppose you have given 8 electron volt. 2 electron volt uh, is spended to overcome the work function, and 6 electron volt is spended. 6 electron volt is spended in the collision of the electron with other electron. So total energy you have expended. 6 plus 2, 8 volt. Now kinetic energy of the ejected electron will be 0. For example, another example, you have given 8 electron volt. 2 electron volt is wasted here. 2 electron volt is wasted, not wasted. 2 electron volt is used to overcome the work function. 7 electron volt is wasted in the collision. Now, is it possible? 7 plus 2 is 9 electron volt, and you have given the energy of 8 electron volt. So, in this case, the electron will not eject out. Okay, electron will not eject out in this case. So, no electron ejection. Because the here in this case, what is happening? You are providing the 8 electron volt, but here 7 electron volt energy the electron is spending. 7 electron volt energy is spending in the collision. What is the remaining? 1 electron volt, but the requirement of 2 electron volt will be there for the to overcome the work function. That is why the electron is not ejecting. So maximum kinetic energy of electron is this. So maximum kinetic energy of electron will be E minus work function. Okay, will be energy supplied minus the work function of the metal. You can see here all the time what we were doing, we were just subtracting this 8 minus 2 is 6, E minus 5 is the kinetic energy. Now we are getting E minus 5, kinetic energy 6, 8 minus 2 means E minus uh, and E minus this. Okay, now it is not the kinetic energy. This is not the kinetic energy. This is the maximum amount of kinetic energy. Maximum amount of kinetic energy will be there when there will be no energy wasted in collision. That will be the maximum kinetic energy. Okay, so this will be the maximum kinetic energy. So basically, this is the maximum kinetic energy will be E minus 5, energy supplied minus the work function. Now I can write kinetic energy maximum as K max. E is given by H into frequency minus 5. So we can write kinetic energy maximum is equal to Hc by lambda, also we can write to energy minus 5. And this relation is given by Albert Einstein and known as the Einstein photoelectric equation. These equations are known as the Einstein photoelectric equations. Equation. So maximum kinetic energy of electron is equal to the energy of the photons minus the work function of the metal surface. Phi is the work function. Okay, take the screenshot.
Done.
Okay, done. Done. Scroll down, Matthew.
Yes.
Okay.
Done.
Now we will discuss the threshold frequency. So basically, there is a minimum frequency required to. There is a minimum frequency of incident radiation should be there so that the electron will come out or electron should eject. That is known as the threshold frequency. The minimum frequency of incident radiation which may cause the photoelectric effect. Okay, or the electron should eject from the surface. We know that for electron emission, the energy supplied either greater than the work function or equal to work function. Either greater than the work function or equal to work function. Then only there will be the electron emission. So we know that energy of the photon E has the formula H into F. This can be written as greater than equal to phi. Phi is the work function. From here you will get the frequency that is greater than or equal to phi divided by H. So now you can say the max frequency of incident radiation either greater than phi by H or equal to phi by H. So what will be the minimum frequency will be equal to phi by H. Minimum frequency will be phi by H. From here you will get a new formula. Phi is equal to H into F naught. What is F naught? F naught is the threshold frequency. Now we know that this relation. We know this relation. E kinetic energy maximum is equal to E minus phi. We know this relation. So now from here we can write kinetic energy max. E can be written as H into F and phi can be written as H into F naught. H into F naught. Now this equation I can compare it with y is equal to mx plus c. Mx here will be minus c. This is the equation of the straight line. So we will draw the graph between maximum kinetic energy and the frequency. We'll draw the graph between the maximum kinetic energy and frequency. So this is the equation of the straight line. So we will get a graph, the straight line graph with having a negative intercept of h into f naught. So this graph we will get. Okay, maximum kinetic energy of electron versus frequency of photon. So you will get this type of graph. Okay, you will get this type of graph. You can draw this with a dotted line. and this is the negative intercept, and this intercept have the value h into f naught. This have the value h into f naught. You can see here y is equal to mx minus c, and this value will be f naught, because after this frequency na, there will be the ejection of the electron after the threshold frequency. If you have a frequency less than this frequency, there will be no electron ejection. If you have a frequency greater than this, then you can see there will be the kinetic energy, and when there will be a kinetic energy means the electrons is already ejected out. So this is the threshold frequency. Now we will have threshold wavelength. We will have threshold wavelength. So threshold wavelength, like what is threshold frequency? The minimum frequency of incident radiation which may cause the photoelectric effect. Threshold wavelength is the maximum wavelength of incident radiation which may cause photoelectric effect, or the longest wavelength for which there will be the photoelectric effect. Threshold frequency, threshold wavelength, and this threshold wavelength is represented by lambda naught. Lambda naught. So the longest wavelength of incident radiation which can cause the photoelectric effect. Okay. So we will calculate what is lambda naught. For electron emission, we know this relation, and we know E can be written as Hc by lambda also. E can be written as Hc by lambda, and this Hc by lambda is greater than or equal to 5. We can write, and from here we can get the lambda. Lambda is less than or equal to Hc by 5. Lambda is either less than Hc by 5 or equal to Hg by 5. So what will the maximum value of lambda? The maximum value of lambda will be Hc by 5, and this Hc by 5 is lambda naught. Lambda naught is what? Threshold wavelength. So what is the value of the threshold wavelength? Lambda naught is Hc by 5 naught. So from here you will get the new formula for phi. Phi is equal to Hc by lambda naught. Now you have this relation, maximum kinetic energy is equal to E minus phi. So maximum kinetic energy can be written as E can be written as Hc by lambda. This E can be written as Hc by lambda. This phi can be written as Hc by lambda naught. So there will be a graph we will draw between the maximum kinetic energy and 1 by lambda. So a straight line graph we will get from this equation. Y is equal to mx plus c. Mx plus c. So here it will be minus c. And what will be the slope of this graph? Hc will be the slope of this graph. This m is the slope. Okay. Now for this graph, I have not written the slope. So if this angle is suppose theta, so slope of the graph is given by tan theta. And here the slope of the graph from the equation, m is the slope. When you will compare both the equation, you will have the slope of h. But in this graph, you will have a slope of hc, because there is a graph between 1 by lambda and maximum kinetic energy. So this kind of graph you will have, straight line graph. And this value is 1 by lambda naught. And intercept is hc by lambda naught. You can see here, hc by lambda naught. This is the intercept. Okay, take the screenshots. Done?
Just
Yes, sir.
Okay. Just a minute.
Yes, sir, done.
Okay.
Yes, sir, done.
Okay. Okay, so after this, we will discuss the relation between the maximum kinetic energy and the intensity of the radiation. So how the kinetic energy maximum of the ejected electron will change when we will increase or decrease the intensity. So basically we know that the maximum kinetic energy of a ejected electron is E minus phi. E can be written as HF minus phi, and maximum kinetic energy can be written as Hc by lambda also minus phi. Now you can see kinetic energy maximum is depending either on the frequency or on the work function. Either on the frequency or on the work function or on the wavelength. So kinetic energy is basically is depending upon the is depending upon the frequency, work function or the wavelength, not depending upon the intensity. Okay, not depending upon the intensity. So basically, kinetic energy maximum of the electron will not change if you will increase the intensity of the radiation. So we can write here on increasing the intensity of radiation. On increasing the intensity of radiation. The number of photons increases. I told you that on increasing the intensity of radiation, what will happen? The number of photons will increase. The number of photons will increase but energy of each photon will remain same. I have given the example of the bulb. The number of photons will increase, but energy of each photon is still same. Hence, now you can see here, kinetic energy maximum of the electron is depending upon the energy of the photon minus the work function, means depending upon the energy and work function. Energy of the photon will remain same on increasing the intensity of radiation, and work function will also remain same because work function is depending upon the surface, nature of the surface. until and unless you will not change the surface, there will be no change in the work function, and there will be no change in the energy also if you will not change the frequency. So maximum kinetic energy will remain same. Hence, maximum kinetic energy of photoelectrons, hence maximum kinetic energy of photoelectrons. Photoelectron means the electrons which are ejecting. Photoelectrons is unaffected, or you can say is not changed. Change with intensity of radiation. Intensity of radiation. So that is why you can see here kinetic energy maximum of the electron is just independent of the intensity of radiation. You can increase the intensity of the radiation, kinetic energy maximum will remain same all the time, because the kinetic energy of maximum is depending upon the energy and work function. You can write here kinetic energy maximum depends on number one, energy of photon, energy of photon, or you can say frequency and wavelength of photon, because energy can be written as energy of photon can be written as hc by lambda, or it can be written as h into frequency. Now we'll solve questions. So in this question, it is given that work function of a substance is 4 electron volt. Work function of a substance is 4 electron volt. Find the longest wavelength of light. Find the longest wavelength of light that can cause photoelectric emission. Longest wavelength means they are asking lambda naught, threshold wavelength. Now what is given? Given is the phi is given. Phi is given as the 4 electron volt. 4 electron volt is given, and we have to find the lambda naught. Lambda naught means we have to find the threshold wavelength. So we have this formula, phi is equal to hc divided by lambda naught. So put the value of phi, put the value of h, put the value of c, you will get the value of lambda naught. So I am telling you one shortcut to calculate the phi. You can calculate phi like this. If you can write energy is equal to hc divided by lambda. Okay. So this energy you can write like this. 1240 and lambda here you will put in nanometer, and you will get the answer in electron volt. Okay, if you will put lambda in nanometer, then you will get the answer in electron volt. So if you will use this formula, you have to calculate the hc, but here directly you can get the answer. Now you can calculate from here, because phi is given in the electron volt, so this value is already in the electron volt. It is equal to 4, and hc is 1240 and lambda. So lambda value you will get in nanometer. It will be 1240 divided by 4. So it will be 310, I think. 3 1s are 3. It will be 310 nanometer. 310 nanometer. So in this way you can calculate. Either you can calculate from this formula also, or in shortcut you can use this. Energy can be given as 1240 by lambda, but you have to put lambda in nanometer, then you will get the answer of energy in electron volt. For example, I am saying lambda is given as 310 nanometer, and for this lambda calculate the energy of photon in electron volt. So what you will do, you will use this formula 1240 by lambda. Okay, so you will get 1240, lambda is 310 nanometer, lambda in nanometer, you will get the answer 4 electron volt. This is just example. Okay, another question. So in this question, you can see there are two metal surfaces. There are two metal surfaces. One is this having the work function phi, and this metal surface also having the work function phi. So these radiations of lambda 248 nanometer are incident on the surface. Here the radiation of wavelength 310 nanometer is incident on this surface, and here the electron is ejecting from this surface. Here also the electrons are ejecting from the surface. From here also the electron is ejecting from the surface. V1 is the velocity. V1 is the velocity of electron ejection. Here V2 is the velocity of electron ejection. Ratio of V1 and V2 is given, and Hc is given as 1240 electron volt nanometer. They are asking work function of the surface, because these are the same surfaces, so that is why the work function is same. First, the radiation of lambda 248 is incident on this, so the electron is ejecting, and for that ejection, the velocity of the electron ejection is v1. Second time, the incident radiation of wavelength 310 nanometer is incident on the surface, and the velocity of ejection of electron is v2. Ratio is given, and this value is given. We have to find the work function. Okay, so suppose this is the first case, this is the second case. Okay, now for the first case we can apply this equation. Maximum kinetic energy of ejected electron is equal to E minus phi. So now in this case, if you will apply, so kinetic energy of the electron is given by half into mass of the electron into V1 square. Okay, so maximum kinetic energy in this case will be half m into V1 square, and E can be written as Hc by lambda 1 minus phi, because phi is there. Okay, Hc by lambda 1. Now it can be written as half into m into v1 square. This is equal to Hc is having the value 1240 electron volt nanometer. So it is 1240, and lambda 1, if you will write in nanometer, so nanometer and nanometer will be cancelled out. So lambda 1 is given as 248 nanometer. Okay, and it is minus phi. This is equation number 1. Now second, for the second case, you can apply this equation. Maximum kinetic energy minus E is equal to E minus phi. So maximum kinetic energy in this case, for the second case, will be the kinetic energy of this electron half m into v2 square. It will be half m into v2 square is equal to, it will be Hc by lambda 2, because here the wavelength of the light is of lambda 2, we have assumed. This is 310 nanometer, and minus phi. Now it can be written as half into m into v2 square is equal to hc is given as 1240 and lambda 2 is 310 nanometer and it is minus 5. This is equation number second. So we have to solve equation number 1 and equation number second to get the value of phi. To get the value of phi, we have to solve equation number 1 and equation number 2. So now I am dividing the equation number 1 by 2. Divide the equation number 1 by equation number 2. So what is the equation number 1? Half m into v1 square. This is divided by half m into v2 square. This is equal to 1240 divided by 248. 1240 divided by 248 minus 5. This is divided by 1240 divided by 310 minus 5. Okay. Now this half m will be cancelled out. So on the left hand side we have v1 square divided by v2 square. So on the right hand side when you will cancel this term with 248, so it will be I think okay, trying with 4. So it will be 4 3s are 12 and it will be 210. 4 3s are 12, 4 1s are 4 and it will be 0. It will be 4 6s are 24, 4 2s are 8. Now try it with 62. 62 5s are 310. Now try this. This 10 is cancelled out with 10. 31 4s are 124. So we will have 5 minus 5 divided by 4 minus 5. So you can write this thing as v1 by v2 square, v1 by v2 whole square, and that is equal to 5 minus 5 divided by 4 minus 5. v1 by v2 is given. Ratio of v1 by v2 is given. That is 2 ratio 1. Okay. v1 by v2 will be 2 divided by 1. So it will be 2 divided by 1 and square of this. It will be 5 minus 5, 4 minus 5. It will become 4 by 1, 5 minus 5, 4 minus 5. Now cross multiplication with this and cross multiplication with this. So you will get, when you will do the cross multiplication of this, you will get 16 minus 4 5 is equal to 5 minus 5. So you will get 16 minus 5, 11 is equal to minus 5 plus 4 5. You will get 3 5. So work function 5 you will get 11 divided by 3. So it will be 3.666 electron volt. This will be the final answer. So you have to apply this equation, Einstein's photoelectric equation, in first case as well as in second case. After that you will have two equations. You have to solve those two equations and you will get this part. Understanding, Matthew, Nawal, Nafisa?
Yes, sir.
Okay.
Yes, sir.
So here you will see that the maximum kinetic energy. Okay, maximum kinetic energy of what? Maximum kinetic energy of the electron that is ejecting out. Okay, why the Einstein give this relation, maximum kinetic energy? Because we cannot calculate the exact kinetic energy of the electron, because electron, when the electron is ejecting from the surface, always remember that there will be other electrons also. So there can be the collision also from other electrons and energy can be wasted in that. So we do not know how much amount of energy is wasted, but we know, we can understand, we can evaluate. If there will be no collision, then there will be the maximum amount of kinetic energy, because no energy is wasted out of the given energy. That is why this relation Einstein has given. Okay, so take the screenshot. Done.
Yes, sir.
Okay. Scroll down. This means move to the next slide.
Just
Okay.
Yes, sir.
Okay. You can ask me to scroll up also. Okay. Completed all of you? Matthew completed? Completed, Nafisa?
Yes, sir.
Yes.
Okay. Now see once again. We have discussed dual nature of matter and radiation. Okay. So basically, radiation have dual nature, means wave nature as well as particle nature. Matter also have particle nature, wave nature. After that, I discussed the photoelectric effect. What is photoelectric effect? When the incident light or when the radiations or photons are incident on the metal surface, electrons are ejected out. This phenomena is known as the photoelectric effect. After that, I discussed the work function. What is the work function? Minimum amount of energy required to eject an electron from the metal surface is called the work function, and work function is represented by phi. For example, the work function of this metal is 2 electron volt and you are providing the energy of 2.5 electron volt. If there is no collision of electron, ejected electron, then 2 electron volt will be spended to overcome the work function, and 0.5 volt will go to the kinetic energy of the electron. Okay. You have heard, means familiar with ionization energy. Ionization energy. And what is the ionization energy? Ionization energy is the energy given to the electron so that the electron is removed from the shell. Okay. To remove one electron, the energy given is known as the ionization energy. So like this also, you are giving some energy and this electron is ejecting out from the surface. Okay. So what is work function? Minimum amount of energy required to eject an electron from the metal surface is called the work function. Okay, this statement you have to remember. If you are giving the energy greater than the work function, then it is possible that electron may not come out, or may come out. Why? Because some energy can be wasted in the collision also. After that, I discuss the maximum kinetic energy of the electron. This is given by the Einstein. Maximum kinetic energy of the electron is energy of the photons. E is the energy of the incident radiation, or you can say energy of the photon minus the work function. And we know that energy of the photons can be written as hf, or it can be written as hc by lambda also. So this is Einstein photoelectric equation. After that, I discussed the threshold frequency. What is threshold frequency? Minimum frequency of incident radiation, which may cause photoelectric effect. Okay, you can see from this relation, we know that uh, energy supplied for the electron emission from a metal surface, energy supplied must be greater than or equal to work function. From this relation, we get the minimum frequency, that is f naught. So there is a relation phi is equal to h f naught, and when you will put in this equation, you will get this equation, and when you will draw the graph between the maximum kinetic energy and the frequency, you will get the straight line graph with a negative intercept of h naught and slope of h. After that, I discuss the threshold wavelength, the longest wavelength of incident radiation which can cause photoelectric effect. For electron emission, same phenomenon process you will follow, and you will get phi is equal to hc by lambda naught. And when you will put in this equation, you will get this equation. So this equation is an equation of a straight line. If you will draw the graph between the maximum kinetic energy and 1 by lambda, you will get this straight line graph, and this graph have this slope. I have not written the slope. This graph will have the slope of m. So when you will compare this equation and this equation, you will have the slope hc. Slope of this graph will be hc. Okay. After this, we discussed kinetic energy of incident. Maximum kinetic energy is not depending upon the intensity of the radiation. Why? Because maximum kinetic energy is depending upon the energy of the photon. If you will increase